Hi there, Engineering Science. Mr. Young here again, back with another energy video, this time potential energy, looking at the potential energy formula and how to solve the three different kind of problems that you may encounter with this. Again, linking into a wee bit of maths here and looking at, what potential energy is measured in. If it's an energy, we should know that. And looking at the different elements of the formula. Let's have a wee look. So, potential energy, as you can see down the bottom, is equal to mass times gravity times height. Now, again, potential energy, since it is an energy I've just mentioned, is always measured in joules, and mass, as we've probably encountered before, is measured in kilograms. Okay, and we've also encountered gravity before, so these are elements that we've come across before, and gravity is just our constant at 9.8 meters per second if you want to be precise, but just 9.8, we'll deal with it the way that comes. You can see that actually potential energy has been shown in the formula at the top here as EP, so potential energy, or energy potential if you want to call it that. This energy is every object and item, or every person as well, has potential energy inside them. It's a sort of energy of storage, I was going to call it there, or stored energy. So if something's not doing anything, or if an object's not doing anything, it has energy ready to be used. So as we always say to pupils, you all have potential inside you, so it's kind of similar to that way. So if you think of an object maybe sitting at height, it could be a cup on a table. It's still got some sort of potential energy. It's sitting with something inside it. Anyway, so looking at that way, we're going to use this formula now just to kind of sort out or show, three different ways of, solving particular problems that would come up with this. So we'll have a look at that now. So I'm going to run through a couple of, or three in fact, potential energy problems, just looking at the formula there we just saw. Potential energy is equal to mass times gravity times height. And the first one here is just looking at a winch. You can see it here as a mass of 100 kilograms, and it lifts a mass of 100 kilograms at a height of 20 meters. Calculate the minimum amount of energy used to raise the lift. So again, we're looking at EP, or potential energy, is equal to mass times gravity times height. And always be able to start, it's always good just to kind of start off, saying what the formula is, and then you got the mass, 100. So looking at going with the formula here, mass, gravity and height. So mass is first, 100 times the gravity, what's the constant of 9.8, times your height, which is 20. Okay, so you can multiply those out. So when we do this, then we've got 100 times 9.8 is going to be 980 times 20. So you're looking at a total here of 19,600. Always remember units, joules. So 19,600 joules. You can also convert that back into kilojoules. So that'd be 19.6 kilojoules, just to make it a little bit easier to kind of write out instead of having to write out the whole thing there. You can either do it this one straight away if you know what the answer is, 19.6, or put this in and then convert it or change it over. But if you can do that, that's much easier there. Okay. Now, looking at second question here, what we're looking at this time is a ball that's sitting on a wall. It rhymes, that's good. Well done me. Potential energy of 10 joules. I have to think about that one there. Calculate the mass of the ball. So this time, this is what we don't know, is the mass. Okay, so what we generally do is if you cover up the mass here, you can even do it with my wee pencil. What we're looking at this time is the potential energy is going to be divided by the gravity times the height of the object, or the height of the object sitting on. So mass, so this time we're going to work on mass, that's what it's asking us for, is equal to potential energy divided by gravity times height. That's how we do it. So we'll cover that up, and then we'll look at what's on top and divide that by these two items on the bottom, which are always multiplying each other. Okay, So this time we've only got 10 joules, so it's not a very big thing, divided by the gravity, which is 9.8, times the height, which is 5. Okay, so what we're best doing here first is we're best working out this bottom bit first. Don't just do 10 divided by this times this, because you'll end up with a bit of gobbledygook, possibly not the correct answer. So what we're best doing is doing 9.8 times multiplied by 5, and we'll find the answer. And that gives us an answer of 49. So now 10, so we now know that the bottom is 49 and the top is 10 divided by 49. Which is going to then give us 10 divided by 49 then, is going to give us our answer of 0.2. The mass is always in kilograms, so 0.2 kilograms. So not very big, not very heavy ball, but 200 grams or so it's not that heavy. So our last one here we're looking at is looking at the height of an object here. So we've got a car with a mass, 1,000 kilograms. I should say a car with a mass of 1,000 kilograms. It's on a bridge. It has a potential energy of 29,500 joules, so 29.5 kilojoules. What is the height of the bridge? Okay, so we're looking at the height this time, so we're looking at this area. So again, if we cover this up, we're looking at potential energy divided by the mass times the gravity. Okay, so again, height is equal to potential energy divided by mass times gravity. Okay, and again, as always, we're going to work out the bottom bit first. So mass 1,000 times 9.8 will give you about 9,800. Oh, I put a 0 there, but it's still the same thing. So it's still going to be 1,000. Or 29,500, 29,500 divided by this times this. So I'm going to work out this bottom bit first. So as I've said, that gives us 9,800. So 29,500 is your potential energy. And we're working out the height, remember? Height, H still there. Put it in there as well. So what we're looking at there in this time is dividing that by that. So we're going to get probably a relatively small number, and it ends up being just about 3 meters. The height of this bridge is very small, but we're still following the correct process. And sometimes you can put in these numbers and make things up to practice the formulas, and you'll still find out sometimes you get like a really odd number coming out, but it's still correct because we followed the correct procedure there, so it still looks good. So that's it. Remember, height's always in meters. Now check the units from the other ones. Yep, put 0.2 kilograms and joules for the last one. Okay, so that's how to work out in 3 different ways how to work out the potential energy of something, how to work out maybe the mass of something, and let's swap this over, how to work out the height of something. Okay, and that's how you do it, by covering up what you want to know and looking to see what's left. Alright, as simple as that. You don't need to worry about gravity because that's always constant, 9.8. Alright, well, as we always say at the end here, or I try and say, hopefully that was interesting or gives you some idea of how to tackle this. Hopefully you're all staying safe, and thanks for watching.